excited to listen to what you have to say. And he is analyst product manager working for Synchrony. Probably you met him at the event a few weeks ago. And he is a leader in cloud technologies, and if you have any questions, ask him about the cloud. And he has a very interesting multidimensional talent. He has over 13 years of experience in building analytic solutions for financial, telecom and media companies. He is currently working at the intersection of identity, mobility and analytics, and believes data is the currency of tomorrow. And this is the other dimensions of him. Outside of work, he enjoys listening to Indian classical music and performs stand-up comedy on weekends. He is working towards his 1-hour HBO special that combines comedy, analytics, and cryptocurrency. Okay, so.
Thank you, Mr. Dr. Good morning. Happy Valentine's Day. So, despite the Valentine's busy schedule, you guys came. It's a great achievement. So I'm going to start off. I'm going to make this very interactive.
You have nothing else to do.
Yeah, you have nothing else to do. So you need to have a life outside of class then. So I'm going to make this as interactive as possible so that you can participate. The idea is to compress 8 to 9 years of my life into 3 hours to try and teach you what little I know about this. I have some goodies here. You can help yourself between the breaks. I have some exercises that I want to do with you to get the point across what I'm trying to say. So how is this going to be organized? I'm going to talk a little bit about history, about how we got here, why data, why analytics, then talk about OLTP, OLAP, SMP, MPP, talk about data warehouse design, what goes into data warehouse design, why we should do things one way or the other. I have some videos to show you, I have some personal experiences. All my material that I look at the PowerPoint is from Google. Nothing is private or synchronous or me. So don't worry about the PowerPoint, it will be available to you, take it as you want. I am here to give you my perspective on what's already out there. So I'm not going to say anything new, but I'm just going to give you a real world perspective of what actually happens, right? So let's begin. You know this, right? So what follows after this? Right? Everybody else. You can switch off all the lights. Great. So what's the agenda, right? Analytics and evolution. We're looking at aspects of why you should care, what you're going to learn from it. Here are other aspects you look at: business objects, MicroStrategy, those aspects of those things. So hopefully you learn something useful from it, right? Okay. So how many of you here hate history? You completely hate history. Never like history classes. So of those who hate history, how many want to do analytics and predictive and machine learning, all that good stuff? So you know the paradox, right? History repeats itself. So if you hated history, no way you can predict the future. So along the same lines, I'm going to walk you through a little bit of how we landed here. Now, most of the stuff that happened here, you weren't even born. Your parents didn't meet. So this was like really, really ancient ages. But it's important for you to know because you will appreciate where we are and why we are studying what we study, right? So this to me was the most important aspect of why we are here. This is the birth of the transistor or the integrated circuit. And this is when Moore's law began taking shape. He predicted that the power of computing will surpass anything that you've seen before for a long time to come, right? And that was 1980s that it started. And if you can see here, 1980s with integrated circuits, 1985 or 1990 was the birth of data warehousing. Because the more data you could pack, the more computing you could pack in a small piece of computer chip, the more you could do with the data. You had the power now to do more with it. That's where we were. And let's look at how engineering matured as a result of it. Now, this is the uniprocessor and custom CPU era, meaning we always thought that one CPU was enough to do what we're supposed to do, and that was that era, and that led to this idea of symmetric multiprocessing. I'll come to that, I'll cover that a little bit. This is fascinating. Look at this here. Whereas most of the problems of the information reporting were solved, around the 2000s, we got to know the first idea of big data. So you know why big data, and it's a marketing term. This was there all along. This was there 1999 when I started school. It happened. You know why data was such a big deal in 2000? Y2K. People had no clue. Like, can you imagine such bad programming that if you change date from 1999 to 2000, you have 3 zeros after a number, programs would crash. Simply horrible programming back then. So what they had to do was take all the data, back it up, and redo it all over again. So when they began backing up data, that's when they realized, oh my God, I had so much data. That was the birth of big data. They didn't call it back then, but that was also the emergence of massively parallel processing. That's when they realized that we have so much data now, we want to play with it. Single core architectures won't help us. We need more computation to do the things we need. So you can see symmetric multiprocessing started in 1990s, almost is on the way in 2010, and massively parallel processing starts about 2010 and is doing really well up to now. What is symmetric multiprocessing? I'll get to that in a moment. Now, evolution of data in general, right? Flat files, hierarchical network, object-oriented, object-relational. You remember object-oriented programming? Object-oriented databases were also a thing. But the problem was, since the object could hold any amount of data, you really didn't know how much was coming in. So, to give an example, if I were told to process data from a data source, me as a SQL developer, I try to put it into a table, rows and columns. You as a Java developer would take it as an object. Would you know beforehand how much data is coming in? Unless you perform advanced skills, you wouldn't know. That's why object-oriented databases didn't take off that much. And as you can see here, all these data sets existed, but data warehousing took off 1990. Again, simple processing, single processor, right? And this is where we as BI or business intelligence professionals came into fore, because the users began asking a lot of questions of the data. Do you guys know the company called Enron? Enron, there was a scandal. Yes. So Enron was a company who had massive fraud in accounting, meaning that the numbers that were made by the accountant that went to the CEO were heavily fudged. They had inventory that they declared inventory that they never had. So the single grain of truth was consecutively deflated and inflated by the time it got to the CEO. And this is the reason why analytics is now that much important, because it's a fact. It's a measure of truth. And that's why it's very powerful. Especially the guys who work in data visualization, they have a very, very tough job of showing the truth, the whole truth and nothing but the truth. And most times, the truth is not what you want to hear. Your business is not doing well, and most of the times the messenger gets fired, not the faulty all the time, right? And that's what so if you can see here now, data warehouse appliances came into being in 2009. You must have heard of Dell appliances. They had these custom-built hardware machines that crunch data in a super fast fashion. 2008, that came into fore. And 2010, this is when we came into this field of SSD, NoSQL. NoSQL is NoSQL. NoSQL is not only SQL. Doesn't mean NoSQL, okay? Hadoop came into place, search. Now, this is very interesting. It's very interesting. I'm going to cover that in the next lecture. But we are now looking at a time and age where searching is business intelligence. Searching is analytics. So in the traditional analytics model, you ran a report, the dashboard told you something. But what users are now asking is, if I can search for recipes for cooking, why can't I search for my answers? They want to type, what is my revenue by Southwest region in Q1 2014? They want to search that, I want to get the answers. So that's evolving. Why? Google. Millennials are more and more influence technology like never before. You out there, anyone less than 25, you're influencing technology in a huge way. And that's search BI. I'll cover that in the next lecture. So now that we've seen, why should you care? Why should you care? So this is what you may want to take down. Analytics comprises of four things. Descriptive, predictive, prescriptive, cognitive. Descriptive, predictive, prescriptive, and cognitive. What does that mean? As you can see in the value chain, I put a timeline. I also put across value and earning. So if anybody who did attend the class and you want to make them feel jealous, you can tell them that people got as a formula to make exponentially more money than ever before. Because what you're doing here also has the opportunity to make exponentially more money for you and exponentially add more value for your businesses that you want to work with. Right? So early 1990, 80s, 2000, Descriptive. What happened? I had this huge historical data I had never had access to because of Y2K. I put it into a database and I was looking at what's going on? Why did I crash? Why did my sales not do well? Did Katrina happen? Do hurricanes have an impact on my business? All that what happened in the past, looking back, that came into force. 2000, 2017, predictive. What's going to happen? How can I make it happen? How can I not make it happen? What's descriptive? If it's going to happen, what can I do to make it happen or make it not happen? To give you an example, right? Let's say that you are a telephone customer. You use a mobile phone all the time, and the CEO has come and told you, tell me who are going to leave me in the next 3 months. Predict. Okay, so now of the 20 people here, I can tell these 3 are going to leave. Great. So now what? So the CEO is going to say, well, tell me how to stop it. But damn it, you didn't ask me that question. You simply said who's going to leave. That's what happens. You told them they're going to leave, but how do I prevent them from leaving? Behavioral analytics. Because each 3 of them have different reasons why they're going to quit. She's bothered about data. She's bothered about call quality. And he thinks Teamable simply sucks. So for all the 3 people here, most probably with all the data we have, we can only retain her and her. Not him, because he's made up his mind, and his reason for leaving Teamable is completely arbitrary. This is what's going on right now. You do not only want to say what is going to happen, you want to say how can I either make it happen or make it not happen. So what's happening in cognitive? And I think this is something that's going to shape the world in more ways than one. In fact, the way I see my kid when he comes out of school, he's going to learn that and not all of these things. That's artificial intelligence. You're going to find ways, newer ways to look at data and make automatic decisions. So I'll give you a very, very interesting example. So how many of you have heard the API called TensorFlow? Yeah. TensorFlow is an API published by Google, which does artificial intelligence, meaning it takes data, learns, and predicts. Basically, it's a fancy neural network that learns by itself. So Google relates its API, and the whole world is saying, how do I use it? One Google engineer used TensorFlow to help his father sort cucumbers better. This is very fascinating because his father back in China, he had a huge cucumber farm. And in cucumbers, the ones that have a lot of thorns on them are the ones which are very, very expensive. People love them a lot. And when his mom tried to sort cucumbers, her hands would get injured. And nobody wanted to sort cucumbers because there's a chance that it may injure your hands. So he was thinking, how can I do this in an automated fashion? How can I teach a machine to look at cucumbers and figure out thorny, non-thorny, and sort it out? So he took a camera, took pictures of all cucumbers possible, fed it to the API. The API understood, learned over a period of time. Have you heard Raspberry Pi? It's a small processor. So he built a machine that on the conveyor belt taught the machine to go either 0 or 1. 0 meaning non-thorny, 1 meaning thorny. So as the cucumbers came in, he took the picture, the machine said 0 or 1, and the conveyor belt split it. By doing that, he saved his mother maybe 60% of her working hours by, instead of sorting cucumbers, she helped on marketing. So this device, this API is free. This device was maybe $2,000. They made they not only recovered the money, they made 8 times more profit just because of this. This is one guy solving a very rudimentary problem using artificial intelligence. This is going to be the world that's going to shift. So why should you know? Because the world is changing. Let me put it more bluntly. Descriptive analytics, if you're going to go out and get a job, will feed you for 5 years. Predictive and prescriptive, next 10 years. Artificial intelligence, next 20 years. So your jobs and my job are going to be defunct in 5 years. And I'm only doing this. I know a version 3. I'm not doing that. I'm just doing this. That's where the world is headed. You have to be knowledgeable. You have to know what's going on and keep yourself abreast of how can I be competitive in the changing landscape. Okay, I often speak very fast. If you don't understand what I'm saying, please tell me to slow down, I will. If you have questions, it's okay to ask questions. I won't kill you for it. Okay? So any questions so far? Should I proceed?
Can I ask you a question? So AI is actually not new, right? So
Yes,
it
it's
has
not.
been around for more than maybe 35 years or so. And at that time, all AI folks thought that everything would replace, all over the world, it will be replaced by AI technologies, and it never happened, people are still in the loop, and we don't see a lot of AI being deployed in many, although there is some kind of data mining, data analytics, and there are some feedback loops around, but it has not taken off the way they predicted. So why do you think it will revolutionize after 2015?
Because
why do you think your kid will be AI kid?
Because there was one guy who had nothing else to do on a Sunday afternoon, whose kid was sitting there playing with a toy called Hadoop, basically jobless fellow. Instead of playing with his kid, he created this concept called Hadoop. That changed the world. For the first time in life, you had this opportunity to process massive data at a super low cost. Give you an example. If I were to process 1 terabyte of data using Netezza, let's say it costs $10,000. With Hadoop, I can do it for $1,000, 3 times faster. So why? Again, she's right. I did my project on neural networks 2002. It was back there, it was famous. What was the problem? There was no way to process that much data as fast as I can. There is no point in having neural network return data after 6 months. I need stuff to happen right now. That is what has happened. The moment this Hadoop guy came into the picture, he changed the landscape. You are now able to take data, put it into memory and process it. Spark has made it even faster. If Hadoop was the old grandfather, Spark is the kid who's running so fast you can't catch up with it. Spark for the first time did something very amazing. So now in the hardware and software world, right? Hardware world brought down multi-core processing, multi-RAM, huge RAM processing long time ago. Unfortunately, software didn't catch up with that. So have you heard of Java Lambda, Java 8? This is the only version of Java that's truly using the power of parallel processing. Java until then did not do that. I mean, that's shocking. Usually software engineers are the smartest kids and they trailblaze the whole world. Hardware here was ahead of the time. So now what Spark is doing is, rather than doing batch processing on disks, it's taking data in memory and making it much faster. I'll tell you a little example for this. And this is happening right now. So suppose you're having a bad day, you're having call drops all along, and you want to yell at your carrier operator, say, what, screw it, I'm done with it. So let's say you place a call, 9 a.m. you place your call, the call goes through. Let's say it takes about 60 seconds for you to talk to a representative. You know what goes on back then? Here's what goes on. Your data is being fed saying this guy is calling. As soon as you call, the data underneath gets activated saying this guy is calling. Why is he calling? What happens? Algorithms run at the background. They're trying to figure out why is he calling. It looks at behavior, in the locality, blah, blah, blah. By the time you reach there, there's a screen for the operator which says, this guy could be calling for A, B, and C. 60%, 20%, 20%. So even before you tell them what you're calling about, he's already figured out what you're calling about. And for each of these actions, he has 3 other blocks telling them what to do when you say either of these things. This could not have happened long time ago. What's happening? You have massive amounts of data. You have neural networks, artificial intelligence, predictive algorithms running. You have your data going in, algorithm runs all over again and predicts what you're calling about. And you can take an action on 60 seconds. Spark. There are technologies that will come which is going to be even faster than that. But I'm telling you, all these are now useful and able to compete because of that. That's the reason why all the data scientists who are famous today are usually over 50. Because this is not new. Big data is not new. AI neural networks are not new. These are there long time ago. Just that we figured out a way to process it faster. Right? Okay. So, what is the problem? In true Valentine Day fashion, we'll do some Romeo and Juliet business. Right? You look at 2 people, Romeo and Juliet. One is a corporate user who has their set of problems to solve. Another is the user. doesn't care about the corporate, just wants to do his or her own business, right? So what does Juliet want? She wants to buy jewelry, she wants to buy a bag, she wants to buy perfume, and she should not get an out of 404 error. She should always have her products available all the time, very, very cheap. Typical, right? I mean, all customers want everything free, fast, wonderful, lovely. Typical. What do the Romeos want? The practical lovers. They say, you know what, we'll do all of that. I also want to know what's going on. Are people buying stuff the right way? Are there any clusters, any examples, any patterns that I can see, that I can exploit for my personal gain? So there is this world and there is that world. And we're going to look at how analytics helps solve that throughout. So through both these parlances, I'm going to use throughout in my lecture to tell you how each of them will be satisfied through the use of analytics. Okay, so before I start this OLTP, I want to do a little exercise. I need 3 volunteers who have not talked to each other before. 3 people on stage. Preferably strangers, or I'll pick. Don't be shy. Okay, you give me the glasses. Come on. You, sir, one more. Wonderful. On stage. Okay. So what we're going to do now is, this is a Rubik cube. People know Rubik cube. What I'm going to do is, I'm going to ask these 3 people to solve the Rubik cube. And through that, I'm hoping to teach you SMP and MPP, right? So here's your task. So here's a Rubik cube, right? Now you are the audience. I want you to tell me what's going to happen. Now I'm going to tell her, solve the Rubik cube. I'm going to say, take her 10 minutes to do it. So let her try. After 10 minutes, I'm going to say these 2 guys to help her solve it. There's only one Rubik cube. I want to tell them to solve it. Let's see what happens. So let's try. Let's try to solve the Rubik cube if you can. No? Any color, shape or form doesn't matter. Okay, so we made it long enough. I think that fast processing has to happen. So I'm going to ask these 2 gentlemen to help her with it. So why don't you help her with the processing of the cube? You keep at it. I'm going to tell them some story. I will keep at it. So in this case, the Rubik cube is a computation. The hands are the RAM. Now, how fast can they make the Rubik cube happen? If they have more hands, more Rubik cube, or more brains?
More brains.
More brains? But they have 2 hands.
Yeah, it's just one Rubik cube and the 3 people working on it. So no matter what, it's the brain, the processing that has to take place faster. Nobody knows how to solve the Rubik cube, the algorithm behind it. Nobody knows how, no matter what, even you give them an hour, they'll still be figuring out, even for the last block, probably getting more confused.
So was it fair to say that because the Rubik cube is shared by them, it is limited by that idea that they can't process it fast enough? Because they have shared the Rubik cube?
Yes, probably.
So let's stop. Okay, let's do another thing. Right? So now what if I took this Rubik cube, right? And I said, I cut this into 3. I give each one of them a section. Then I tell them, they don't use their processing at all. I just tell them, align in such a way that the bone, the fish and the thing come together. Do you think then they'll be able to process it faster? Because they have they have now 3 equal pieces of the Rubik cube? I'm telling you. So I'm going to take away the thinking ability from you. I'm going to only let you the doing ability, so that there's no contention for intelligence. I'm going to be the node for it. Right? So do you think they'll not do better? So if I split it up into 3. So in the first case, thank you for your time. So in the first case, they shared everything. They shared the cube, and they were limited by what they could achieve because everything was shared. In the second case, they shared nothing. They took the cube. I took the cube. I gave them individual pieces. I asked them to work on it individually. The point is this. Let's say that all have the same IQ levels, and everybody has had coffee today. So let's say they'll optimally work on that speed, 10 rotations per minute. What is the speed of the overall procedure? What is the maximum speed that can happen? The lowest speed of the person? The link is as strong as the weakest link in the chain? Fair enough? This is shared nothing. They share nothing. They have the individual pieces of work and they make it happen. The first case where they shared this is called symmetric multiprocessing, or SMP, which were the databases that were there until 1990s. In the second case, when they did not share the Rubik cube, it's called shared nothing, called massively parallel processing. What happens now? Here's what happens. Now, if I had told them, I'll make the cube bigger, and I'll say, do it in half the time. No matter what happened, in the first case, they would never be able to solve it. Because I'm reducing the time and I'm giving them a bigger workload. In the second case, when I split this up and gave it to them, I would say, do it faster. They could, because they have only smaller pieces to work with. Now it depends on how fast I can pass on instructions, how correctly I can pass on instructions to them. So in the massively parallel processing case, the master node is to be smart, to know what is the processing capability of each node on the network. So she was a node, he was a node, and he was a node. They were nodes. So no matter how much the capacity was, they were limited by the weakest node in the link. Symmetric multiprocessing, massively parallel processing. This has significant impact on why analytics is key today. And massively parallel processing is the core idea that led to Hadoop and big data analytics and faster processing. We'll come to that in a moment. So any questions there? Have you understood shared everything and shared nothing? Other clear? Any doubts? Shared everything and shared nothing? In shared everything, all the resources are shared across every people, no matter how fast you input, because everything is shared. She's going to end up saying, you know what she'll say at that moment? God damn it, I have two hands. I have a lot of brain power, I have a lot of CPU, but I have two hands. I am limited by the memory I have. Why are you telling everyone to do the same job? Why don't you give me 3 different Rubik cubes? I'll solve it. Shared nothing. Shared everything, shared nothing. That's where it goes. Okay? Now, why are OLTP so important? Here's a key idea for you. If you go out in the job market, nobody is going to ask you to design an OLTP system. Nobody. It's done and dusted. OLTP systems have been designed already. They don't need your expertise at all. But you need to know this so that you appreciate what data processing is, what reporting is, and what analytics is. So what are the typical use cases of OLTP? Reliability. Right? Because let's say this, right? You want to book a flight and all of you log in at the same time and I want to book 10 flight tickets. How do you ensure that the first 10 get the tickets and the remaining ones don't? Second case, what if you add the ticket to the cart but don't check out? Does that count? Because you have actually taken stuff off the shelf and put it in my basket. You haven't checked out, but the stuff is gone. Then whom should I prioritize? So all these nitty-gritties of making sure the transactions are true throughout the process are the job of OLTPs. I am going to ensure reliability at all points in time. So that when you, the customer, are going to buy your stuff, you will always get a reliable experience. No matter where you log in from the world, these systems have to work exactly the same way. They have to work on whatever internet connection you have. You have mobile connection, you have this connection, it has to work exactly the same way. So those are the features of it. Now, why am I talking SMP with OLTP? Any idea? Why am I clubbing SMP with OLTP? Okay, so when she was doing her Rubik cube thing, right? Let's just say I put in a word to her and say, turn it such a way that the Mario's head is on top. I pass second instruction saying Mario's hand is on top, Mario's leg is on top. She possibly can't do all 3 things at a time. She can do only one thing at a time. SMPs, though they are very limited in their processing, are good at one thing: reliability. who sent the instruction first, their instruction has to be locked down. She's going to come and say, I have 2 hands. The fact that you have multiple people helping me cannot help me because I just have 2 hands. I'm going to do it. I'm going to take only 1 instruction at a time. If 10 people log in and want to buy a ticket, I'm going to prioritize the first 10 transactions no matter what. So though SMPs are used to handling smaller data, they do reliability very, very correctly. Acid? Anybody? Sulfuric acid? No? Not that acid? Which acid?
Properties of database?
Which are?
Atomicity, consistency, and integrity and redundancy.
And?
Durability.
You all had coffee today. Nice. So all databases must do that. And SMPs have to do that. SMPs and OLTPs have to do that. If they can't, no matter what they cannot do, they cannot query fast, they cannot give me massively beautiful reports and charts. They have to ensure consistency, durability, and reliability. Otherwise, e-commerce will fail. Internet survives today because you have asset transactions and reliable databases. Imagine if you're not able to trust Amazon in what you want to buy. Why would you go to Amazon? Forget the analytics it does for you. Forget the fact it shows you customers who bought this also bought this. That's greed, right? They know that, man. They know. We're greedy people. They know that. All that can happen only because they can transact well, they can transact reliably. How does it typically look like? Same way. 2 more people helping her out, 2 more CPUs. She already had a CPU. She had a hand. What was she limited by? 2 hands. Memory. The shared cube was the memory. There's only 1 Rubik cube. She could not have done anything better. SMPs are awesome at this. OLTPs work on this very well. What are the pluses and the minuses? These are the good ones. Lower administrative cost, small cube, nothing much to manage. Typically in big corporations, 1 DBA manages 4 or 5 OLTPs, very, very cheap. Reliant and very well suited for transaction applications. What are the flip sides of things? Efficiency. And no matter how much awesome hardware you have, you cannot use that for SMP because you're limited by how the database is designed. And my experience is it cannot work up to 2 terabytes and more. 2 terabytes is a stretch because MySQL, MariaDB, Oracle now can do all of that. Previously they couldn't even do that much. But still they have a place and a time for using SMPs and OLTPs. No questions so far. Are you awake or? Awake? Yes. Okay. Okay. So why should we do it? Because FastBuy, the company that we're looking for, wants to help customers buy products as fast as possible. Because they want to make sure that the performance is stable, and they may not let people check out more products fast, but they will make sure that they're reliable. They will not let 20 people log in per minute and buy stuff, but they will definitely let 10 people buy products in 2 minutes, all the time. And believe me, in the longer run, reliability is always better than speed. Speed you can always increase, you can redesign everything, but to build your trust, you need to have reliability. That's why SMP databases exist. OLAP, OLTP, OLAP. Field of analytics, we are all very jargony. We like to throw around this OLTP and OLAP, it makes us look very smart. It's not a big deal, but it's just a way of marketing it, making it easy for you to understand. What's analytic processing? Remember the 2 boxes we had, Romeo and Juliet? We helped Juliet with her shopping. She's happy now, right? Now what? Romeo has a problem. You know what? Juliet is happy, I'm not happy. Let's make Romeo happy. What does he want? He wants access to data. He wants it fast. He wants it now, and he wants it at a speed of light. Of course, we can give him that, but we'll give him the next best thing. This is why you need OLAP. I want to pause here and make you understand a little bit of terminology. OLAP as a concept is a birthright sort of say for Microsoft SQL Server. Microsoft sort of owns this terminology because only Microsoft database truly does OLAP. Others do data warehouses. So Q, OLAP. This is OLAP. Why? You can switch, you can turn around, you can look at slice and dice and grain of data. So when we say OLTP and OLAP, it's not a truly fair comparison. We should say OLTP and data warehouse, because processing data along a queue is best done by Microsoft and by nobody else. Others try to imitate, but Microsoft does it best. I'll tell you why and I'll tell you why. Right? But general idea is that now that you've stored data, OLAP technology, OLAP concepts help you understand it better faster. Here are the reasons why. Massive parallel processing. Right? Now I took the Rubik cube, I split it into 3, right? One block, second block, third block. I played coordinator, 3 CPUs and coordinator on top. So here's the beauty. This could be a 4-core i7, 16 GB RAM, 200 GB solid, 256 GB solid state hard drive. This could be anything else. Don't care. Right? Because the coordinator can decide what data is provided to you and how much you can process. However, the first few days of MPP, Teradata, Exadata, Greenplum, InfoBright, all those guys, what they did was, though this concept can truly scale out to any hardware configurations you want, they wanted a monopoly. So what they did was, they said, you the IT people, don't worry about all of this MPP stuff. Please give it to you. We'll give you a physical hardware box. So typical Netezza box is, how can I say, twice as big as this and twice as huge. It's a physical hardware box, and it encapsulates all of that into that box. And what they have done, they have maintained similarity across. All the CPUs, the memory and the hard disk are of the exact same size and configuration. They run at exact same speeds, temperature, blah blah blah. So they can optimize it even better. So now what's happening? Let's say I have 100 terabytes to store, right? Previously on an SMP, one single queue, I can partition it only so many ways. I can say the business needs reporting by day, month, week. I can partition along those lines. Here, it can be even more creative. I can say, let's partition by month. So this guy has January, February and March. It can be even more creative. Partition by the products being sold. What I'm typically saying is, the older products that I sold are not as important as the newer products. So if I'm selling 10 products, I can put all 5, old 5 in one bunch, keep it here. The remaining 5, I can partition across all 3. Creative partitioning is now available to you because of this architecture. Otherwise, it would be very, very difficult to do this on the SMP shared everything model. Any questions so far? Am I going too fast? You able to comprehend me? Okay. What's the good and the bad? Huge amounts of data. And if you look at it, if you really look at it, is this not one SMP by itself? So basically an MPP is an SMP running in parallel. So you could ideally take your laptop, connect to all the other laptops and make an MPP right here. Just that the coordination becomes a problem if you have different configurations. That's why you have these hardware that are built specifically for processing where the coordination is taken care of. Temperatures, the architectures of the CPU, the RAM, SDRAM, DDRAM, solid state hard drive, non-solid state, i7, i4, AMD, all of that is taken care of. So what are the positives? It can run many SMPs in parallel. Data is not a problem. Here's the beauty. So in my work, I moved from SQL Server about 600 gigs database to Netezza, 600 gigs. The problem with the SQL Server, again, shared everything, was that I had to be very, very careful about partitioning. In Netezza, I went, the DBA said, give me one flat file. Don't care about the number of rows. Just make sure you give me a good primary key. You know how beautiful it was? For SQL Server, I had to write 80 queries, spend 16 hours debugging those queries, and had to run it every day. In Netezza, just join all the freaking tables, load one table, one data all the time. So I went from 16 hours, 80 queries to maybe 2 minutes and one query. Just imagine the amount of time I have saved. Cost was very expensive. This cost $6 million, I think. That machine cost maybe 600K. But I save huge amounts of time. I could be more productive with that application. So, massively parallel processing systems, data is, number of rows is not a problem. If anybody kids with you saying, oh, MPPs cannot handle 2 million rows, they're lying. Number of rows is not a problem. You have to just be careful about maintaining uniqueness throughout the data. You have to have one primary key that's unique across all the rows. That's the only problem you have to solve. That's why DBA's work is much more in the massively parallel processing systems. If you want to be a DBA who's an SMP and an MPP, the MPP guy makes a lot more money. Because he has to be very, very careful to say, I'm going to design the database correctly, data correctly to ensure uniqueness across all the data records. That's one thing. I said to you, you can participate any way you want to. You can just go bonkers with it. Your business has newer needs now. Oh, I'm the hero, man. I can do anything for you. You can just be bold and say that. You want a new partition strategy, you want reports in 30 seconds, no problem, sir. Anything I can do for you. Scale linear CPU memory. So if you have one Netezza box, and suppose say reports are running in 3 minutes, put another box 1.5 minutes. Put another box or 45 seconds. Put another box 22.5 seconds. Linear scale. Very, very hard to achieve, but that's the beauty. If you have a similar configuration running, scale is linear. What's the bad? Text analysis. I'll tell you why. Text is very, very unique in that it cannot, it has to look at semantics. So it's Valentine's Day. I love you, right? Now, I love, after that what? You is meaningful. I love bananas. Okay? So you can simply say both texts are the same, but they're not the same. You and bananas are different. So semantics come into play. You have to look backwards to understand the context, not forward. That's why massively parallel systems cannot do text analysis very easily. You have to look backwards to see what the context was. Are to humans speaking or to monkeys speaking? Because you would expect monkeys to say I love bananas, not humans. Not monkeys to say I love you, right? So that might change. Again, it's not suited for predictive analytics. I'll come back to that in a moment. Because the cost is so expensive, you can't really use massively parallel systems for predictive analytics stuff. Okay, so what does it solve now? Remember the fast by case, Romeo and Juliet, both are now happy. We are now able to satisfy the Juliets, the Romeo, the Juliets of the world by giving them SMP and OLTP, and we managed to keep the Romeos happy by giving them MPP and OLAP. Right? So let's do something. Laptops. Can you open up your laptop? Let's do something. Let's do something in action. Let's do some OLTP design. Just to wake up your fingers and get your brain started. So this is a true invoice that you get in real life. We're now going to walk through what OLTP design means. How we can take this data and build an OLTP system around it. Right, so open up your laptops. Prof, you break at 1 hour. You probably not 10 minutes. How many of you have classes after this one? So you definitely need to leave by 12:45?
Yes.
Too late? Well,
Right on time.
you have something to eat here. So don't give me that excuse. I've got stuff to eat. So eating is not a problem. Don't run around for that. Something useful you'll learn. So you want to grab a bite, there's food to have here, go and grab. This is enough nutrition to last you through lunch. You can take 2 if you need to. So I'm going to end this at 12:40. I want to keep you longer than that, but depending on the questions you have. Okay, so everyone laptops open? Fabulous. So what is this? This is the invoice. This is what the world looks like. Every time you do a transaction processing, you sell or buy something. There's no point in having a transaction if you don't sell or buy. And this is a real world invoice. Now let's look at how we can translate that. So if I take this invoice now and put it into a tabular format, would this be appropriate? What I did here, what does it have? It has customer ID, name of the customer, right? If you want to use something later on, you should give an ID to it. Put a ring on it, put ID to it, right? Customer ID, name, the address where the customer exists, the date of the purchase, and identifier to say which order it was. You know, so some guy says, well, you ordered 10 things and I bought only 2 things. No. Order ID is that, and this is what you did. Okay. What did you buy? You bought 3 things. What are the names? Fancy marketing names. What quantity? What is the price? And what is the accepted price? How much did you buy it for? 800 to 1600 total price. Let's look at now putting it into a repeatable format. Here's how it is. Okay, just to see how much you've already woken up. What normal form is this? How many normal forms are there? 7, 8?
Five normal forms.
Okay, 5. Okay, which normal form is this? Sorry? Don't be shy. It's okay to be wrong. Which normal form is this? Dude, you have to know this. You're doing advanced database. This is 101.
One.
Why 1NF? What does 1NF mean?
What's normal form
Redundancy
says there
is-
should be only one value per cell, isn't it? I mean, in the table, when you're adding a value to each cell, then there should be only one value. There should not be more than one.
That's the literal implement. That's a literal
Yeah.
analysis. So the layman language is, the moment you put data into a table, it becomes 1NF. Why? Because you give a structure to it. You are now for the first time reading data in a structured manner, meaning if I were to load many other invoices, I can load it in this format all the time, meaning data is not variable column. This is the primary difference why structured and unstructured data vary so differently. Unstructured data, example, take a newspaper and try putting it into a table. What are you going to say? Page number 1, column number 2, heading pink and green? No, it's going to be bunkers to unstructured data. It does not fit the first normal form itself because you cannot put data into structured format repeatedly all the time. Right? For first time. What did we do? Okay, we said what did we say? We said order ID, we have the dates, the customer ID, again, 2 customers. We put the product name, the customer information, all that. The very fact that you put data into a table is 1NF. What should we do? This is what we should do. Take the data and suppose you were to design a transaction system. What would you do? Would you have a order entity? Would you have a customer entity? Would you have a product entity? Would you have a vendor who supplies the product entity? Is that fair? Vendor, product, customer, order. Vendor may be not so important, but for a customer to, for you to exist in the business, you need a customer. To sell something to customer, you need a product. I need to make sure that you sell at a higher price than you bought it for. So you model it this way. What does second normal form say? Eliminate partial dependency. What does that mean? That's what I explained. You take out the data and put it into separate entities because you don't have dependency on anymore now. Because I can say, where can I get customer information repeatedly all the time consistently? In the customer entity. Where can I get the product information? In the product entity. If I club it together, if a product changes, what do I have to do? Change all the tables again. Imagine in that previous model here, if I had to simply go and change the product name, I had to repeat this whole thing all over again for the entire table. Rather than that, if I just cut out the product piece, put it into its own table, I can update the product itself. I don't have to touch the customer, the order and the vendor. Right? That's second thing, second NF. What's third NF? Transitive dependency. What does that mean? Okay. Can the order exist without the customer? Can the order exist without the product? Can the order exist without the vendor? Nice. Good coffee, my friend. Good. The order can exist without the vendor because the vendor only supplies the product. The ordering is not depending on the vendor doing anything. Once the product is in, it's fine. But purchasing the product, is vendor responsible for that? I have to purchase the product from somebody, the vendor. Is the customer responsible for that? No. So what I'm trying to say is that the ordering aspect is independent of the vendor, but the purchasing from the vendor is independent from the customer. So when I do the database design, I have to not only eliminate dependencies, or to eliminate transitive dependencies, or to keep everything in its own place and make it refer to itself. 1NF, 2NF, 3NF. So what's the salient feature of OLTPs? They have to be 3NF or higher. If you see a database model, how will it use OLTP or OLAP? It has to be 3NF or higher. So what does it look like? This. So what are the features? You will have, they are normalized, meaning what? You will have all stuff by itself, all for one for all, one for each. Selfish, normalized. I don't share anything to anybody. I'm just me, selfish, me, ego. Normalized, OLTP. Supplies to itself, orders to itself, order details, everything to itself. What's the advantage? I can update only those things that change and not affect anything else. Right? Write, delete, update many, read once. Because they are small, because data is small, and I am always, remember, what am I optimizing for? Reliability. Don't care about speed. Do not care about speed. I am always going to make it reliable. So I am going to give importance to the write, delete, updates over read once. So what does it mean? If a transaction fails, it's easier to correct that mistake because you have a smaller data set. It's normalized. Fewer tables and each entity is independently available to each itself. Small storage, again, third NF for higher. So, any questions on this? This is important because I'm going to take this example and explain to you how data warehouse design works. So far so good? Okay. Fabulous. So now I want to tell you a little story. Dimensional modeling again is not new. It existed for a long time. Have you heard of the guy called Ralph Kimball? If you are going to work in the field of data warehousing, data analytics, you have to know who Ralph Kimball is. Ralph Kimball is the first gentleman who understood that the OLTP model cannot help in faster reporting, cannot facilitate analytics or any of that sort. You can say that he found a very elegant solution to the problem of how can I get results faster, repeatedly, and in tune with business needs. So what is dimensional modeling? It is taking the data, breaking it up in such a way that it facilitates all these things. It can facilitate faster reads, larger storage, and because of that it has to have third normal form or lower. OLAP are denormalized, the complete opposite of denormalization. So how does that work? They say, all thing of beauty is a joy forever. Keats, right? Yeats, what's his name? What's the poet? John Keats. All are engineers, huh? No reason for romance or anything of that sort. So he designed a very elegant solution. Why is it so beautiful in design? Is because it works repeatedly all the time across databases, across geographies, across internet terminologies. That's why it's so elegant. And I'll show you that in a moment here. What are the salient features? There are two kinds of tables now, dimensions or facts. Again, remember why this came, because Enron massacre happened. There was a huge accounting fraud, the same numbers are not repeated all across. So this model answered that question saying, how can I take the single grain of truth, preserve that grain throughout many iterations. So what it said was, I'll build a system where the truth is represented as it is, no matter who accesses that truth, what point in time, the truth and the whole truth is represented. So it met a very high ethical standard, and that's why it's so elegant, right? And it forms a star structure, and very importantly, it's modeled on a business process. Now let's take the invoice example. What are the business processes that happened here? I, as fastbuy.com, purchase the product from a vendor. So purchasing is a business process. If I don't do that, nothing can happen. Fair enough? Okay. So what happened? The product was there. The customer bought the product or ordered it. So the business process is ordering. So when you order, what happens? You pay for it. Business process, payment. What happens? You ship it. How many business processes? Purchasing, ordering, paying, shipping. 4 business processes. So if I were the CEO, if I'm going to figure out how is my business doing, if it's doing good or bad, I want to optimize, make more money, would it not make sense more intuitively to look at each of these processes and say, am I doing good, bad, ugly with that, and either tune them plus, minus, up, down to make sure I earn a profit at the end? So for me to succeed, I have to look at the business processes, what's going on, and tune them for my personal gain at the end. So what's a very, very key element of a data warehouse or dimensional modeling? It reflects the business process. Business is king. That's why MBAs make more money than you guys. Okay, simple reason. They are closer to the business. Business makes money, finance makes money, money runs the world. Your data warehouse has to always answer this question. If it doesn't do this and does all of this, be sure to lose your job. Many data warehouses are, okay, here's a question. Of the 100 data warehouses that are being built, 80 of them fail. 80% fail rate. This reason alone. They do not model business process. You're trying to measure something that's not even a problem. What's the point? You're trying to create an artificial problem and solve it. What's the point? Not many immigrants are coming from Mexico are liars and drug addicts. What's the point of building the wall? Solving the wrong problem. Solving the wrong problem. Data warehouses fail. 80% data warehouses fail because they don't solve a problem that exists. They solve a fictitious problem. This is very, very important for you to know. All of these will follow. So what are the key things data warehouse should do? It should define business processes, such as ordering, purchasing, shipping, payment. It has to define reusable information. Okay, Sachin Tendulkar, cricket, wonderful. Sachin Tendulkar scored 100 runs, right? 100 runs. So what is 100 runs here? What is it? It's a measure. Perfect. If I take out the whole sentence and just say 100 runs, does it give you meaning?
No.
Okay, forget. Sachin Tendulkar scored. Does that give you meaning?
To some extent.
Scored is 0. I'll be sorry for that. But other people might be happy. But it gives you some information, but doesn't give you all information. You need to have it together. So, in a sentence where there is a numeric quantity associated, which has to be repeatedly used throughout, is a fact. Fact that happened. Tendulkar scored 100 runs. Fact, truth. Always repeated across time. Who scored 100 runs? Why is it so important? Because if I want to talk about Sachin Tendulkar's life history throughout, what will change? The number of runs. But what will always be constant? Sachin Tendulkar scored. He may scored it in Gaba, he scored it in Bangalore, wherever in the world. But that will remain. So the information that I can reuse all the time is a attribute. Related attributes grouped together are called dimensions. So here is the first measure of your success. If what you have built cannot be reused more than once, it's not useful. If I'm talking about cricket, there has to be a mention of Sachin Tendulkar. Who cares about Vinod Kamble? Tough luck, right? So, if I'm going to use cricketers, right-handed batsmen, I have to make sure they've been used so much throughout. But if I'm going to use terminology of Chinaman bowlers who use their ball with their hands up their heads, how many guys, right? 2 or 3 maybe. So, they are not going to be used as much. So, the information that I'm going to have that can be repeated, reused again and again is a dimension. And what am I associating it with is a fact. So what dimensional modeling does is it takes a table, breaks it down into a dimension and a fact. And that's the whole play here. Lowest grade of analysis. So in this example, in the invoice you saw, the data was at the day grade, meaning transactions happened in a day. So if I were to go and ask, Professor Ratluri here as a business process and ask her, say, would you like me to analyze data by hour, by quarter, or by year? She'll say hour. Do you think we can do that? Why not? You can do anything, man. Rock stars. Why? What can't do it by hour?
The lowest granularity of data is by day.
The lowest granularity of data is by day. You cannot measure data lower than what it's present at. You can make assumptions. You can do predictions to say that if I have 30 transactions in a day between 9 a.m. to 5 p.m., I can extrapolate that to say 30 divided by 9 is so many transactions per hour, but I can't be sure because I may do it this way. Other guys would say nobody buys between 12 to 1 o'clock. Screw that. So I'm going to extrapolate that between 9 to 12 and 1 to 4. Only those hours. So in the second case, my extrapolation is going to fail because everybody has a different measure of doing it. So what is very, very important? Define the grain. The business user is very, very right in asking the questions. You cannot say that that's a stupid question. The only thing you say, data doesn't support your decision. Garbage in, garbage out. Your analysis is as good as the data going in. You cannot have data at the day grain and ask for hourly grain. Not possible. But if your data is at the day grain, can she ask for month and quarter and year? Let's roll up, right? You can say, what happens here. You can, she can come and say, well, I don't want the year to end on December 31st, I want it on March 31st. It's fine. You can have one view, you can have another view. But at least the basic low grain data supports it. And so that's very important. So that's the grain definition. Okay? So, what does it look like? This is beautiful. Nature loves symmetry. The sphere is the most natural form matter exists in. You know why? Equidistance from the center. Very, very sensible of nature to put stuff in that manner. Not a square, not a rectangle, not a triangle. Very, very beautiful. So if you look at it, this is almost in that case. So if I were to have more dimensions surrounding a fact, it almost looks spherical. There's an elegance. That's why Ralph Kimball is he has such a big standing in the industry. He modeled analytics in terms of how nature looks at things. It's very elegant in that sense. So I talked about dimensions and facts. Here's the beauty. The facts reside at the center, dimensions surround it. So let's say Professor Toi's question is, I want to know by customer, by month, how many products were sold. By customer, by month, how many. So the moment somebody tells you by, how many, your by becomes your dimensions, how many becomes your fact. Simple design. Very, very simple. The moment they say by, you're going to sit in a class where they say requirement gathering, it's a terminology used. Let them talk all the crap. How is the weather, do you like the Knicks game, whatever. Say by. That's not the by song, right? Not that one, it's a different song. So, at the moment you say by, that's the dimension. What I want to measure by is the fact. What are the ideas behind it? Metrics define business process. The metric, the fact table here, we should have one fact table per one business process. Write it down, memorize, eat, drink, sleep it. One fact table per business process. Why? One grain of truth. There is only one way to measure ordering, not 1 way. You can aggregate all you want, but there is only one table that talks per business process. What are dimensions? What are the ideas, what are the elements I'm looking at to measure that business process? So, how is my vendor doing? Has he sold stuff on time correctly? Has it arrived on time correctly? All those things can be answered to that. Reusability. Here's the beauty of it. So when I say what information you have can be reused or not, let's assume this is the ordering process. Right? Now let's look at the shipping process. So I'm going to draw there and maybe we'll drive the point across to you. Right? So let's say I have date here. I have date. I have product. And I have the ordering. Let's say I have purchasing. Okay, so I have a join here and I have two more here, whatever that is, right? Now let's say process purchasing is here. Now I join it like this. What is the one I can have here? Vendor. So now, can you not see that the data and product have been reused across these two? Why should they be reused? Because the question you are asking is, how many products were ordered? When were they ordered? let's say you get a list of products and dates that you are ordering. But let's say you have a scenario where far more products have been ordered than what you can suffice or supply for. What do you also want to know? How many have been purchased? You cannot meet supply if there is not demand. There is more demand, you have to meet the supply. This guy wants 1,000 products here. He's ordering 1,000 products. You need to have 1,000 products purchased. So the fact that these two are reused across business processes make them very, very important. The health of your data warehouse, of your OLAP, is as important as this two. If you, number one, right? How do you recognize failed analytic implementations? Not defined as a business process. Don't have reusable information. So the fact that these two are reused now, we have a special name for them called confirmed dimensions. Confirmed dimensions, because they have been confirmed across multiple business processes. So if you want to look like a star, you look like a hero, have confirmed dimensions. Then what happens is the accounting guy, the ordering guy, the sales guy, and the purchase guy all talk the same language, and those four guys hate each other. In any enterprise you go, the sales, the accounting never talk to each other at all, because the accounting guy says, "Oh, what is sales? Just fluff." What the accounting guy does, all it does is Excel and crunch numbers. What does he know about selling? They don't talk to, they hate each other. But now we're able to get everybody on the same platform, talking and interacting through confirmed dimensions. You may do all the magic in the world, you may have business processes, but you don't have confirmed dimensions, your implementation is going to fail. 100%. Now, I've talked about denormalization. Now tell me, is this model denormalized or normalized? There are only two options. Eeny, meeny, miny. I know that. But when you say, I'm going to ask you why. So, how many say it's normalized? Isha. Normalized? One guy, huh? Not very popular. Two people. Fabulous. Okay. Normalization 1. Normalization 2. 3. Normalization 3, and you go. 3 people are okay. How many say denormalized? Others don't have an opinion? All of you are wrong. All of you are wrong. 3 people said normalization, they are right. And I let them explain why they are right. Anyone wants to explain why it's normalized?
That's what we did for initially. Like when you structured everything in just one single table, you made sure that you want to get everything separate, make sure the dimensions are separate, and like as you said, that there shouldn't be any dependency on any of this table. So even if you get this transitivity, that there's nothing that like you made sure that
they're not interdependent for some information.
Whatever coffee you're having, I want that. They are right. So though data warehouses are called denormalized, this is a normalized model. Where is the problem? Here is the problem. Now look at it this way. Let's say Professor Rathnavali is very, very inquisitive. She loves the data warehouse you built. She asks one question. Now tell me, of the customers who have bought those products, and the moment you shipped it and the moment you purchased it, can I figure out a way where I can group together the products that are being sold to a customer in Newark are supplied by a vendor in Newark and shipped from Newark? So she asked that question. Is it always feasible? Because Amazon has centers all throughout the world. Amazon has, I don't say it's stupid, the best policies in the world. 60% of the time the products that have been sold to me have been shipped from California. Ridiculous amount, that's bad for the earth. Super high carbon emissions, completely inefficient. The funny thing is, California and Newark are the best possible places to ship from because they are ports. If you're going to get stuff from China or from import or anywhere in the world, do it from Newark and close by. They still do it there. Of course, there's something for them to work on, but let's say that's the problem we wanted to solve. So what happens then? The address information can be reused across all. So, I take the customer dimension here, right? Why should address be stuck in the customer? What if I took address and shoved it into supplier information, ordering information, shipping information? would I not be repeating address information in 3 different places? I would. Am I not denormalizing? Am I not making data redundant? How many think that's a bad idea? Dude, man, you have MPPs. Money is not a problem. Storage is not a problem. Denormalize happily. Joy and happiness. Why is it a good idea? Here's what's a good idea. Because if I add a customer address, I don't need to add it to the address dimension and reference it throughout. I can only add it to the customer's address. I don't have to go and touch the shipper's address and the vendor's address. I'll keep all 3 separate. Amazon will have, by any stretch of imagination, Amazon will at least have 100 times more customers as vendors. What value is there in shoving all addresses together in one place where 99% of the time they're going to be associated with customers' addresses and not vendors' addresses or shippers' addresses? There's no value in it. So I'll denormalize. I'll take the address information. I'll keep it in different places. I'll say customer address, shipper address, vendor address. I'm denormalizing. Why? Because then I can insert or update only those and not touch the remaining else. Remember, MPPs are not known for reliability. SMPs are known for reliability. I need to be cognizant of that. To save space, the jugaad mentality, make it normalize all together. This is the real score. It has happened. We've done that. So when you have an MPP, use the database. Use it. Flood it with data. Denormalize to your heart's content. No problem. You maintain integrity there. The moment you do jugaad in MPP, get screwed up. So this is so here's the fun part. If somebody tells you data warehouse are denormalized, in principle, yes. But a star schema is not denormalized. It is perfectly 3NF. A star schema by itself is normalized. The fact that I'm going to split data across multiple views is denormalization. If you ask interview question, denormalization, you need to know the subtle difference here. Right? Okay. What are the best practices? You know what's the world's best product? Two choices. The one that was created with the most innovation, or the one that's being used every day. Most innovation, used every day.
Used every day.
Your data warehouse is awesome only if it's used every day. It may have funky star schema, MPP, or the chain line. Nobody uses it, nobody cares. Our job is number 1 best practice. Make sure it's used every day. The best code in the world is not written on your laptop. It's the one that goes into production. I may write beautiful Java code and memory manage it and all my heart's content. Doesn't go into production, no use. The first key practice, make sure it's being used every day. Fact table for every business process. One business process, one fact table. One single grain of truth. Very, very philosophical this is. Again, remember the reason why. You had a scandal where you took data and everybody fudged their numbers to their own happiness. Business process modeling, single grain of truth. Nobody who accessed it, same thing. Everybody sees $100. Not what you want to see, but that's what everybody sees. No lie, no BS. You can't, if you have a true data warehouse, nobody will say that in the Seattle location the profit is very high, in Portland it's very low. Everybody says the same thing. Nobody is going to interpret it differently. There are no alternative facts. There is only one fact. Nobody gets the joke? There's only one fact. No alternative facts. The grain that meets a business need. She's very right in asking Arlie, politely refuse. No matter, data doesn't support. This meets a business need, that I can give. Multiple fact tables. Again, elegant, right? Beautiful. All I have to do is take this and stick. All it looks like this circle. Data warehouse. Bus architecture. Bus architecture. The fact that you are able to have hub and spoke throughout going in, this is called the bus architecture. This is what it works like. Multiple confirmed dimensions. Multiple reusable information across many business processes. Healthy data values. If you cannot have queries and execute within 1 minute, do something very wrong. The cardinal sin is to do this on an SMP. If somebody else you do data warehouse on SMP, politely refuse. You know what will happen? All of this will be fine. But if the truth takes 4 hours to come, who cares? Especially now because Facebook can like something in a minute. Instant gratification. This is the curse of the United States of America. They brought this gratification of instant, on demand, great marketing ploy, screwed our happiness. Everybody wants reports in 1 minute. They want now reports at the speed of search. Imagine Amazon, right? They are selling products, billions of products every minute. Some nut job in Seattle wants to search for how many products are sold 11:01 a.m. at 11:02 a.m. Who the hell? How is it possible to give you that much data crunching in 1 minute? Oh, Google can do it. Dude, man, unstructured data, that's search, big data, it's a big table, it's a whole different concept. No, I want that. Instant gratification, millennials, 25-year-olds are vessel, world at the fingertips. Snapchat, right? Delete everything, anonymity. Very, very hard. So if you want to design data warehouses on SMP, politely refuse on day one. MPP is the only way to go, and find ways to optimize this. Now, this is a bit of a unethical business practice, I might say. So what they've done is, this concept of SMP, this star schema existed even before SMP and MPP. What MPPs have done is, they have designed their hardware to support this star schema from day one. So I'll show you some data visualization tools. They support star schema from day one. Like imagine being tailor-made for running 100-meter races and nothing else. They don't run marathons very well, but 100-meter races, they are perfect designed for it. That's why analytics has taken off so much. So MPP is the right way to go. Okay, we've used that now. So what I'm going to look at now is explain to you some terminologies that go behind this. It's 11:20 now. We'll break in 10 minutes. In 10 minutes time we will break, not now. Don't everybody suddenly walk out saying break. Okay? So we'll cover 2 or 3 concepts, we'll break for 10 minutes, we'll come back and continue. Alright? So again, I know it's hard, it's a lot of stuff I'm giving out, but the idea is to compress 8 days into 3 hours. How much can be done, we'll see. But I'm hoping that once you take this away, you'll be able to appreciate how much goes on behind this, because the world, as you said, is going to change. You need to know this to operate in the new world. Okay, so what is confirmed dimension? We spoke that. Role-playing dimensions. What's this? Let's say the date, right? This generic date column. What if there was an order date, ship date, purchase date, deliver date? Possible. Those 4 dates are possible. So can I have a shipping date earlier than the purchase date? Exactly. You're looking at me, what are you talking about? So I need to measure that. What happens? So what I do is, I'll have one date column, I'll have one date table, I'll let it play many roles. I'll say the same date in the purchasing business process plays the role of a purchase date. In the case of the ordering is order date, ship date and delivery date. This is jugaad. This is normalization. Why is it okay? Just how many dates I want to have? This each of our days in a year. That's it. What you can't do check back more than that. So you can do it. You can take the role-playing dimensions and more. This is an elegant solution. This is a place where jugaad actually works. So a place, a dimension where it can play multiple roles in multiple business processes based on the need is a role-playing dimension. Geography. Address, right? Purchase address, ship address, delivered address. You're hoping to God that purchase and shipping address and delivered address are the same thing. Right? If not, then what's the point? Customer is unhappy. That's a role-playing dimension. Again, it's a normalization, sacrosanct. Snowflake. Why is it called snowflake? Can you tell? Fancy, right? Marketing term. I think big but nice marketing term. Snowflake. No reason. Somebody made it up. I am telling you the same. I couldn't find a good reason to say why it's snowflake, but it's what it is. What snowflake says is it's a method of normalization when you're saying that. Okay. So one of the implementations we worked with is a customer dimension. Typically, so have you heard of Siebel? Siebel software? Have you heard of CRM?
Yes.
Stands for? Okay. So if I asked you to build a customer dimensions, how many columns will it have? Okay, raise your hands. 100 columns? Okay, 200 columns? 300 columns? You are like, why the hell would I have 300 columns? Tell you what. You have age, you have gender, you have address, all this stuff, right? A little more advanced. Amazon Go, you heard of Amazon Go? The product in Go. Color of hair, color of eyes, gait, female, male, which aisle you walk. The customer dimension explodes by a factor of 10 every year. You have newer and newer people want to track. Blondes are dumb. So they say, right? Biggest race is unknown, unethical, immoral fact. But some dumbos want to measure hair color into customer dimension to see actually do blondes make stupid decisions. Right? Not a fact, it's a plea. They want to say. So now what happens? But you keep that dimension. So now what happens? Customer dimension becomes huge. Now in a business process, do you want your fact table to be big or customer table to be big or dimension table to be big? In your business process, do you want your fact table to be big or dimension table to be big? Okay, eeny, meeny, miny, man, come on.
At least numbers might be fact.
Okay, let's ask you a simple question, right? So, dimension or by what factor? 1 or 2? First tell me 1 or 2. How many for 1? You need to raise your hands for that. I can't see it if it's raising inside your head.
Can you repeat the scenario?
Scenario is, does the dimension table have less rows than the fact table? Or does the dimension table have more rows than the fact table?
In a business situation.
In a business situation. Sachin Tendulkar scored 100 runs. Sachin Tendulkar scored 200 runs. Sachin Tendulkar scored 0 runs. Sachin Tendulkar scored 50 runs. 60 runs. Same story. So tell me now, whether dimension table will have more rows or fact table?
Fact table.
Louder, stronger.
It depends on the situation, isn't it?
So I'll come back to you later. What's the general consensus? Fact table or dimension table?
Fact table.
Fact table? Lock किया जाए? True? Done? Here's the answer. If you have a dimension table more than your fact table, find the nearest exit. Nearest exit, go quietly home. Why? You pray to God that you have so many transactions from the same customer that you can target him more and more. 2 scenarios. 100 customers buying 10,000 products all the time. 20,000 customers buying 10,000 products all the time. Which would you like? Why? Because you can optimize better, right? You can always target 100 customers better. But 20,000 customers, it's harder for you to target whom. What's going to the category spread is so much. It's harder for me. So, what is a good measure of a data warehouse? Fact table always has to be bigger than dimension table by a factor of hundreds. If you're lucky, by millions. Factor of millions. Dimension table has to be very small because to God you're praying, please let me have a dimension table that's small because I can optimize better. 20,000 customers is too much spread. I cannot run marketing campaigns for 20,000 people. I run it better for 100 people. Yes.
If your product is so popular that more number of people want to come for it.
Love it. Still, they're transacting more. 20,000 people are buying 10,000 products. 100 people are buying 20,000 products. 10,000 products. In both cases, if you have similar number of transactions, fact table is bigger. It just so happens in the first case that your dimension table is 19,900 times bigger than the 100K. Not a problem. You would love it. You're healthy. Okay, let's put it this way. This will be healthy. Unhealthy. You hope and pray to God and this is what happens. If you are building a brand new business, this is what happens. When a business is matured, this is what should happen. Initially when you have 5 people signing up, right? Those tricks you guys do, Uber, refer your friend, take this code and buy a cab. What happens? When Uber was first started, 1 people knew about it. 10 people. and they referred. Not many transactions. One guy just took one ride. Does it want multiple? Does not? I don't know if it's safe or not. India especially it's not safe. So one person taking one ride at a time. Then as business grew, same person took many rides. So this is a sign of a business that's still finding its feet. This is a healthy business that's prospering and healthy.
It doesn't depend on the product. It's not like if it's a big purchase, then it's very unlikely that the fact here will have more roles. Considering it's like an expensive purchase.
When expensive purchase is saying more products bought.
If you buy the same person, by the same customer. So it's more likely that more number of people could buy one product.
So then in that case, your fact table will have as many rows as the product table. Which is fine. You are starting up your business, you're trying, you know what, you would love that customer. If one customer buys more products, it's easier to touch them rather than two customers buying, very few products. Because you optimize lesser, right? So, dimension equal to fact, possible. Newer business. Dimension lesser than fact, you would love. How do you know your system is healthy? Dimension much lesser than fact. In fact, 10 times. I've been praying to God 100. And if you had 1,000 times, you must drive a BMW. You must drive a BMW, otherwise you're doing something very wrong. You must have a BMW at this point. Okay, so what does that snowflaking mean? It means that I'm going to take the customer dimension, which has many number of rows, take it out and put it in a separate chunk because the star schemas are built for this. And the piece that I'm cutting off and putting to the side is not reused somewhere. Look at it here. What they have done is take a div brand and div product category out of product. This separately. Why? Because when they use this product in the ordering business process, they don't want to figure out what branding exercise was used. Because branding happens when you sell the product, not when you purchase it. You understand? You don't brand the product while purchasing. You buy an apple. Only when you sell it, you make it Tropicana. You put a beautiful in there and brand it and sell it. So the branding exercise is not relevant to the purchasing process. That's why you keep it separate. Product category. Today you decide this category should be under soft drinks. Tomorrow you say it's health drinks. Why should it be combined with the purchasing problem? Because an apple is an apple. You cannot buy an apple in 20 different ways. You can sell an apple in 20 different ways. So, when do you snowflake? When the dimensions are getting as big as your fact, you have to make it smaller, normalization, and or these two are not going to be reused elsewhere. This information is not required for all business processes along the line. That's when you're going to do it. Netezza, MicroStrategy, it's a tool I'm going to talk to you about, loves snowflaking. By the way, if you tell somebody that, they go an interview and say, have you snowflaked your data warehouse? You're supposed to say no, but it's okay to say yes. You're supposed to say no because it is a sinful thing. You're supposed to, the ethical world, every dimension is confirmed and reused everywhere. So you're not supposed to say I have snowflake. But if you say there's a very valid reason why I have snowflake, you'll get more brownie points for it. You have more chances of getting selected because you did it for a business reason. This is never ever recommended unless there's a very strong business reason for it or there's a very strong data reason. So if somebody says I have snowflake, that gentleman, he or she, should have done something very smart, much more mature. It's very hard to do. Alright, so it's 11:30 now. I have some more stuff to go. Why don't we take a 10-minute break? We'll come back at that in 8 minutes. By Indian stretchable time, it will become 10 minutes. Take a break. If you want to grab something, stuff is here. Let's come back. People who have woken up can stay woken up. People who want to sleep can have a coffee break. We'll be back. 8 minutes. Please, because I have a lot to cover.
Supply chain management professor. So he's asking me whether it's useful for you, but I just wanted to attend the class. So you have done the data
database.
Yes.
No, sure.